So we found for this example then that the inverse of matrix A is 1/3 or 1/13, 5/13, negative 2/13, 3/13. A inverse is 1/13, 5/13, negative 2/13, and 3/13. There is an easier way to solve for the inverse of a 2 by 2 matrix, but this only works for a 2 by 2 matrix. Basically, if you have your coefficient matrix, or whatever matrix you're trying to find the inverse for, find the determinant, take 1 over the determinant, and then multiply by this variation of your matrix. So A and D switch spots, and B and C switch signs. Basically, you just need to know this equation, that the inverse matrix is 1 over the determinant of the original matrix times the matrix where D and A have switched spots and B and C have switched signs. Let's apply this to example A above. Okay. My determinant for A is 3 times 1 minus 2 times negative 5, which ends up being 3 plus 10, which is 13. Then A inverse is 1 over 13 times, I switch 1 and 3, and then I change the signs on the 2 and the 5, which gives me 1/13, 5/13, negative 2/13, and 3/13. Exactly what I got originally, with quite a lot reduced efforts. So notice this equation is very useful for those 2 by 2 matrices. Now we can look at actually solving a system of equations with a matrix equation. So all of this up until now has been telling us or showing us how we can finally solve for those variables x and y. So we know how to set it up as a matrix equation, and now we know how to find the inverse in order to move that matrix to the other side. Now let's look at an example. So in general, we'll have a matrix A times x, y equals our solution matrix B. To solve for x and y, we find the inverse of A, and then we multiply that inverse by B. That tells us our values for x and y. Let's look at some examples here. In example A, the first thing I want to do is set up my matrix equation. I get my matrix of coefficients, my matrix of variables, and then my solution matrix. Now, I want to solve for the matrix A. Actually, I want to solve for A inverse. Because this is a 2 by 2 matrix, I can use my special little shortcut. To do that, I find the determinant of A, which is 4 times 7 is 28, minus negative 3 times negative 5 is 15, so this is 13. Then A inverse is 1 over 13 times, I take the matrix A, switch A and D in it, and then flip the signs on B and C. So I get 7/13, 5/13, 3/13, and 4/13. Lastly, to solve for x and y, I know that the matrix xy equals A inverse times B. In this case, 7/13, 5/13, 3/13, and 4/13 times my solution matrix 3, 1. It's very, very important that you do A inverse and then B, and do not flip them, or else you're not going to be able to do the multiplication. So let's go ahead and multiply these matrices together.